Okay, good day. So in this session, I'll be teaching you how to use Matlab and try to have some basic commands that we could use in solving for some simple problems. Matlab is what we call Matrix Laboratory. It's a math application that is created by MathWorks. Uh, right now, I'm using Matlab 2014B. It's because this one is available to me. Then, I'll be showing you some of the very basic concepts how to work on with the Matlab application. So first of all, let us look at the Matlab environment. So the first thing that you will see on the top is your ribbon toolbar. You have your current folder toolbar, current folder I mean, where you can see your default folder settings for the Matlab. The default settings for the Matlab will be on your documents folder, then on Matlab folder inside the documents. The next one is workspace, where you will see all the variables that you will be using for Matlab. Then lastly, you have your command window for you to work on with your functions and commands that you will be using for a particular problem. So first of all, how would we try to work on with the Matlab application? Now, as you can see, you will be working on the command window for this time. So on the command window, we will be working on with basic arithmetic. So actually, you could input on Matlab some certain operations such as addition. So let's say, for example, 2 plus 2. So the answer is 4. You could actually do different types of operation and it follows the MDAS principle. Let's say, for example, we have 2 times 5 plus 4. So the multiplication symbol is the asterisk sign. But if you would take a look at it, it looks like a star symbol, but it's actually an asterisk sign. So if you have 2 times 5 plus 4, so if you will be looking at that, that would be 14. So the answer is 14. It's because you try to first multiply then add. You could use the answer, your answer, and have it as a operational, have it in the operation as well. So let's say, for example, you have ands, so it gives you the particular value 14. You would see also that on the workspace. Now if I would, let's say, for example, do this answer times answer, it will actually multiply it by itself, which is the answer at that point of time is 14. So when you try to multiply this, you have 196. As you can see right now, the command window is already cluttered with commands. To clear the commands in the command window, you just type CLC. All your previous commands will be cleared out. If you want to go back again to your previous command, you just press the up arrow so you could see your previous inputs on the command window. If you want to clear the workspace, the variables at the workspace, you just type clear. As you can see, there is no value already on the workspace. It's because it is being cleared out. Now moving on, so I'll be typing here CLC. Matlab, from the term matrix laboratory, works in the principle of matrices or arrays. So when we try to work on with arrays, we need to work on also with variables. And a variable could be represented by a letter. Let's say, for example, A is equal to 1. You would see on the workspace that the value of A is equal to 1, or 1, the value of 1 is actually assigned to A, as in programming principle is concerned. It's It's because the equal sign is what we call an assignment operator that assigns a value to a particular variable. You could have a variable as a word. Let's say, for example, var is equal to 100. You will notice that the workspace, the variable var, has a value of 100. So moving further, we could also have variables that holds an array of numbers. We call it as matrix. Now, let us focus first on creating what we call a row vector. So to create a row vector in Matlab, so have a variable, let's say for example x is equal to, we will be using the open and close bracket to indicate a matrix. To create a row vector, you just type your particular values or elements in a row. Let's say for example 1 space 2 space 3. Each element must be separated by a space to create a certain row vector. Once that I press enter here, you would see that the value of x contains 3 elements, which is 1, 2, and 3 respectively. What about column vector? How would we try to create a column vector? To do that is we try to have a variable y is equal to, again, we denote the matrix in the form of brackets. We will be adding elements. Let's say for example 5, 6, and 7 on a column vector. So I'll be putting 5 semicolon 6 semicolon 7. By that we have created a column vector. Each of the elements must be separated by a semicolon to create columns. Now, understanding both the value of x and value of y, if we want to create a n by m size of matrix, we will be using these two characteristics of creating a row and column vector in creating our n by n matrix. So to do that, let's say for example z is equal to, so open and close bracket I mean. So you have, for a row, we'll be first creating a row 1 space 2 space 3. It means at that first row you have 1, 2, and 3 as your element. For the second row, you will have 4 space 5 space 6. As you can see, the separator between rows is a semicolon. Then lastly, create again another semicolon to create your, let's say for example, third row. So this would be 7 space 8 space 9. Notice that we have created already our matrix. So that is how we try to work on or have some basic understanding of how a matrix works. Let's say for example I want to get an index of that particular matrix, or I would want to get the element at the first row, first column. We already know that in that case, if we are talking about matrix Z, the element at the first row, first column is 1. But how do we try to get that in Matlab? So to do that is we have Z, or let's say for example element, the variable element is equal to Z, open parenthesis, that would be pertaining to a particular index, 1, 1. So it gives us the index where that element at matrix Z is located at row 1, column 1, and that would be the element. So the answer for that would be 1. What about on the third row, second column? So that would be 8. So to do that, So that would be second row, third row, second column. So it must be in terms of row, then column. So the answer must be 8. So that is how we try to get or indexing matrices to find some values within the matrix. Now what about creating a array of numbers from 1 to 100? How do we try to create that? Now there are certain ways on how we try to create that, but in simple terms, when we want to create an array of numbers from 1 to 10 within intervals of 1, in Matlab, in its simplicity, let's say for example I want to have a certain variable theta is equal to 1 colon 100. What does this one means? The variable theta will be equal to an array of numbers from 1 to 100 with an interval of 1. So it will start at 1, then we'll go to 2, 3, 4, 5, up to 100. When I try to press enter here, it will be creating a row vector from 1 to 100. It has a value from 1 to 100. Now, I'll be clearing this one so that we have an empty screen. But still, we have our value of data that has an array of 100 numbers from 1 to 100. I'll be creating y is equal to sine. It's a trigonometric function in Matlab that it gets the sine function of a particular value. So I'll be putting this one as sine theta, where your theta is actually a matrix or a value from 1 to 10. So it means that your value of y will be equal to sine times the array. So your y will become also an array from sine theta, where your theta will be starting from 1 down to 100. So when I try to press enter here, you will see that you will have 100 values for y from sine 1 to sine 100. Please take note that the value for this one is in terms of regions when we try to talk about trigonometric functions. Now, let's say for example, I don't want to always display all the values. Let's say for example, if you will be having x from 1 to 1000 and you don't want to display the values from 1 to 1000. So I'll be using our variable theta, which is 1 to 100. If you don't want to show any values from that when you try to enter, you just suppress it by having a semicolon at the end of the command or the function. Once that I press enter, nothing happens. But in the workspace, the value of theta will be from 1 to 100. Now, again, I'll be putting here as sine y is equal to sine theta. I'll suppress it with a semicolon, then press enter. Again, nothing happens. It's because we tried to suppress all the answers and put it into the workspace already. Now, I'll be clearing my workspace. Again, not the workspace, but the command window. So we still have the values for y and theta. If I want to plot the values of y or theta with respect to y, so we could use plot. Plot now is equal to theta, comma, y. So it will give us the value of theta in x and the value of y with respect to theta. So once that I press enter here, it will show a figure of this graph. As you've noticed, it doesn't look like a sinusoidal wave or a sinusoidal, yes, a sinusoidal waveform. The reason for that is because of the values that we have created in theta, where the values of that is in terms of interval of 1. So if you have from 1 to 2, then it only goes to show that the graph or the plot from theta is equal to 1 and theta is equal to 2 and its corresponding y value, it will just only create a straight line. It will form a straight line from x is equal to 1 to x is equal to 2 and its corresponding y values. So as you can see, it has a tip point here. Is because it created, every point will be creating a straight line to its preceding points. So to improve our plot, to improve our sinusoidal waveform, to improve the waveform of our plot, we need to change the value of theta. And the value of theta must be equal to a value on which it has a very fine resolution. Let's say, for example, I put this one as with intervals of 0.1 from 1 to 100. Doing that is by having theta is equal to 1 colon 0.1. It means that you gave an interval to a specific value from 1 to what? 100. So 1 will be your first value and it has an interval of 0.1, so it will start at 1, then the next value will be 1.1, 1.2, 1.3, and as it reaches to a value of 100. Don't forget to put semicolon to suppress the values, is because this would be up to almost 1,000 values. Now, after creating theta, now is the time for us to create also y. Y is equal to sine theta. So to do that, I'll just go up on my command window and find the function y is equal to sine theta. Once that I press enter, again, I put a semicolon to suppress the values to be shown on the command window. Y now becomes also the number of values of that will be also the same as theta, which is almost 1,000. Now when we try to plot again theta and y, you would notice that your resolution for the plot has changed and it becomes a finer shape and a finer sinusoidal waveform. As we move further, it creates already a curve. It's because we try to refine the resolution of our values of theta. So that's good when we try to work on with graphs such as sinusoidal waves, exponential waves, logarithmic waves, so on and so forth. But remember, as you try to increase the number of intervals or decrease the interval, the bigger the memory that it will actually get. It's because it gets a bigger value for that. So please take note of that and try to refine your solution refine your resolution as much as possible to its optimal condition that your computer can handle. Now, moving further, so we have the plot function. So how do we try to create an automation on what we have done right here? So to create our own commands, I would say an own function, we are actually creating a new script. And creating a new script is by clicking on the new or blank script. And from there, you will be creating a function that would automate a specific task. So to do that is we have a function the command function, then I'll add a command name or a file name of the function. So I'll be putting this one as plot xy. Please make sure that your function name or your file name for your script must be unique to the existing commands in Matlab. Most of the commands in Matlab are being run as a function or as a command. And if you have the same name of the function with the pre-existing function in Matlab, it will create confusion on the application. So as much as possible, make your function name or your file name unique. Once that you create the function, then the function name, press enter. I'll be having a value of x. For your value of x, I'll be having a command called as input. Then I'll be having single quote, open and close single quote, enter a number, or enter an array of numbers. So what it does is the value of x, when we try to run this, will be displayed in terms of, it will say enter array of numbers. So it will go through the value of x and I'll be put that as an input. Then I try to enter, then type y is equal to, let's make a different function for this time. I'll be putting an exponential function on the value of y. So that would be e of x. So for me, for using e of x, that is actually exp, open parenthesis x, close parenthesis, times sine x. Just an example of how would you try to do this. If you want to put a negative sign on the x, you just put a minus besides the x to provide a negative value for the x once it is being substituted. So I'll be putting that one. Then when you try to multiply something which pertains to what we call values of matrices, since x is in terms of array of numbers or in terms of matrices, don't forget when you try to multiply to put a dot before the multiplication symbol so that it will not get an error once that we run the program. So we have this function already. Then the next one I'll be plotting, since my function is plot xy. So I'll plot x comma y, then semicolon. Don't forget to save your work. So it will actually go to your Matlab folder. Save it. Then once that it is being saved, you may try to click on run or just close the function and type plot plot xy. When I try to press enter, you notice that it says there enter array of numbers. Again, I'll be using either a bracket or this function 1 colon 0.01 colon 100. Enter. Once I entered those values, you will see now that in your plot you have this specific function. So this is how we try to work on with Matlab, the basics of that. The basics that you try to put commands on the command window, put some functions on the command window, and at the same time create your own predefined, create your own functions that you could use to automate or to ease your working on Matlab. So hopefully by the next session, I will teach you how to actually do some basic programs on Matlab. Again, still using scripts, using loops, conditions, so on and so forth, so that it will make your work faster as you type or as you create your program, so that once that you run the script, it will do the work for you. So again, this will be all for now. See you guys next time.